The question says that we should indicate on a graph the region that satisfies this given inequality, or the region that contains the solution of these simultaneous inequalities. What is the approach to solving this question? The first thing you should do, please mute so that you can get me very well. Just mute. I'm listening very attentively. The first thing you should do is you have identified the two inequalities given to us. What we do next is to get the parent equation of these inequalities. What do I mean by parent equation? For example, the parent equation for 4x minus y less than or equal to x is 4x. The parent equation here is 4x minus y is equal to 8. And the parent equation for the second one now is 3x plus 2y is equal to 12. These are the parent equations. So we are going to use these parent equations to draw a simple line. We use it to draw a simple line. We use it to draw lines. When we are drawing the lines, we now remember that what we are drawing has to do with inequalities. So first of all, we form a table. For this first equation, this one now is the first one, equation 1. This one now is the second one, equation 2. So for this equation 1, we can form a simple table. Look at a simple table where I will have the value of x and a corresponding value of y. When I have x, if here is x, here is y. So if I make x 0, what will be y? And if I make y 0, what will be x? So from here now, from the parent equation, I'll make x 0. If I make x 0 for the first equation, I'm going to have 4 into 0 minus y is equal to 8. This means that y is equal to minus 8. So here is when x is 0, y is minus 8. Also, for me to get the value of x when y is equal to 0, I'll make y 0 in the same equation. So here now I have 4x minus 0 then is equal to 8. So from there now, I will have x to be equal to 8 divided by 4, which is equal to 2. Here is 2. That's for the first equation. For the second equation, I say have my x here is my x, here is my y. For the second equation, so I make x 0 here, and I make y 0 here. I just want to have a straight line. That's what I'm doing here. I just want to have a straight line. From that straight line, I can now, do the inequality. So now, from the second parent equation, if I want to get x, so if I want to get y when x is 0, I will just put x equal to 0. When I put x equal to 0, in that equation, I'm going to have 3 into 0, then plus 2y is equal to 12. Okay, now this means that y is going to be equal to 6. Y is going to be equal to 6. So when x is 0, y is 6. And again, I can do when y is 0. When y is 0, I can make x. I can find the value of x. This means that 3x into 3x is equal to 3x plus 2 into 0 is equal to 12. So here now, this one now will become 0. This one will become 0. So this is x is equal to 12 over 3, which is 4. So x is 4. X is 4 there. So here is, when y is 0, x is equal to 4. So now I have gotten my equations, or I have gotten a simple table for the two equations. So now the next thing you do is now to plot this. We plot this. Here is x, here is y, here is x. So I look at this table, my biggest value here is -8. So I'm supposed to have -8. And here is maybe, here is -2, -4, -6, -8. Here is 2, 4, 6, 8. So that's for the y-axis. Then for the x-axis, my biggest number is 4. Here is 0. Here is maybe, I can say here is 2, or I can use 1, 1 for the x-axis. Here is 1. Here is 2. Here is 3. Here is 4. Here is 5. Then here should be -1. There won't be any need for it. Here should be -2. I don't have any negative value in the x side. So now, I now plot the two graphs. I will now plot the two graphs. I will now plot the two graphs. So when I plot the two graphs, so what I'm going to have, when x is 0, y is -8. 0 and -8 is here. Then the other one is when x is 2, y is, so this one is here, 0 and the 2. So now, immediately I locate the 2 points, I go back to the inequality of the first. So the inequality says less than or equal to. So I'm going to join these 2 points now with a thick line. It's going to be with a thick line. Make sure you use your ruler with a thick line. You join the 2 points. You join the 2 points. So now, again, for the second equation, I have when x is 0, y is 6. When x is 0, y is 6. Look at 6 here. Here is 6. There is 6. So there is 6. When x is 0, y is 6. So we have it at this point. Also, when x is 4, y is 0. When x is 4, y is 0, which is here. I have it there. So now before I join, I'm going to consider the sign again. This is greater than. Since it's only greater than, I'm going to use dotted lines. You use dotted line. I mean that is greater than or equal to, use thick line like the first one. So this one now we are going to use dotted lines to join the 2 points. So use dotted lines. So that one, make sure you use your ruler and dotted lines. So now we have represented the 2 lines. This one now is, no need to write it. This one is the first one. And this one now is the second one. The second one now is actually a dotted line. So what we now do next is we now look at there's something we call what they call it, the point that satisfies, let me call it test of origin. Test of origin. That's what we call it, test of origin. We want to see if the origin satisfies the equation. We start with the first one. If the origin satisfies the equation of the first one, that means that we are going to shade towards the origin as the required area. Or okay, let's shade the the area that is not required. Let's shade the area that is not required so that the unshaded area after we shade will not be our answer. Some people will shade the required area. When you shade finish, you now know where you have overlap. That will not give you your required region. But or if you want to shade out the unwanted area, then the other one you shade out the unwanted area. Notice that anywhere that is now unshaded will be the required area. So what are we going to do here now? We do what we call test of origin. We perform tests of origin on the two graphs. Test of origin, very important. So this test of origin now is what is going to direct you on where you are going to shade for each of the two graphs. Are you going to shade outside the zero, or are you going to shade towards the origin? Are you going to shade outside the origin, or are you going to shade towards the origin? That's what test of origin do. What is that going to do for us? We pick the first equation. The first equation says that 4x minus y is less than or equal to 8. We want to confirm whether this thing is true at the origin. So we put both x and y at 0. If we put 4 into 0 minus 0 is less than or equal to 8. So this means that 0 is less than or equal to 8. Is that true? Yes, that is true. 0 is less than or equal to 8. Yes. 0 is always less than or equal to 8. So that means that the first equation have passed the test of origin. That means that we are going to shade, let's shade the required area. The required area will be this area. We are shading this area because we are going to include 0 or the origin in our shading. This is the required area now, or this area, because it passed the test of origin there. So this origin now, where origin is now, is going to be part of the shading. So this is the required area. Simple. Now, for the second equation, we do the same thing for the second equation. For the second equation, we do test of origin again. Let me just clean here. You have written this. So let me just for the second equation, we have 3x plus 2y is greater than 12. 3x plus 2y is greater than 12. So what is the, we insert x and y as 0. We are going to have 3 into 0 plus 2 into 0 is greater than 12. Is this true? This means that 0 is greater than 12. Is this true? No. 0 can never be greater than 12. So that means that this second one now has failed the test of origin. This second one has failed the test of origin. So it means that we are not going to shade towards 0. We are going to shade away from 0. So we are going to shade this side now. We are going to shade all these sides. These are the required area because it didn't pass the test of origin. So it didn't pass the test of origin. So those are the required area. Remember that this one. So now you now notice that we have shaded out the required area for the two graphs. Now, which region now satisfies the given simultaneous inequality? Which region now satisfies it? That is the bone of contention. Now, the region that have a kind of overlap of the two shadings, where the two shadings overlap, that you know where we are seeing squares. Where we are having squares, that's the region that satisfy the inequality here. Now let me use red and mark it as that's the required region. So the region that has overlap labeled R is the required region that satisfies the given inequalities. Simple. It is very, very clear. What the procedure now is for you to just first of all note the two equations and the form parent equation. From the parent equation, you construct a small table. When x is 0, you get y, and when y is 0, you get x. For the second one, you do the same thing. When x is 0, you get y, and when y is 0, you get x, something like that. Then you plot the two graphs. When you are plotting the two graphs, always remember that once it is greater than, you are going to use dotted line. If it is greater than or equal to, you are going to use thick line. Once it is less than, you are going to use dotted line. If it is less than or equal to, you are going to use thick line. Simple. That's what I did here. This one now is less than or equal to, I have to use thick line. The other one now is just greater than, I have to use dotted line. So after you have done the two of them now, you now a kind of shade. How do you shade the required area? The required area now, for the first one, you do what we call test of origin. Test of origin means you are inserting x and y as 0. What test of origin is helping you to do is to confirm whether when you are shading, are you going to include this origin for any of them? Are you going to include this origin for any of them? For the first one, the test of origin was passed because when we do 4 into 0 minus 0, which will still give us 0. 0 is less than or equal to 8, which is correct. 0 is less than or equal to it makes sense. So that means that the origin is satisfying that particular equation, that particular inequality. The same way we do the test of origin for the second inequality, and we have something like this. 0 is greater than 12. Is 0 greater than 12? No, you cannot come and tell somebody that 0 is greater than 12. So we did that, and we now conclude. We now conclude that the origin for the second one is not true. It's not satisfying the equation. So we shade outside the origin. We are not shading towards the origin again for that one. So on the two shadings, you now notice a particular area that has an overlap. So that area that has an overlap is the required area that satisfies the two inequalities. And it's as simple